Okay, so now they're going to give us some information and they want us to find the magnitude and direction of the vector. They tell us the initial point and the terminal point, and then they want us to draw the vector. So the first thing we need to do is find the standard position of the vector, the position vector. And so we're going to say that's going to be -2 minus -8, comma, -5 minus 1. Okay, so hopefully that's all fine for you. And so we get v is equal to 6 comma -6, and then that is the position vector, or the vector in standard position. Okay, we can draw the vector 6, -6, which is going to be like down here somewhere. Okay, but they want us to find the magnitude. So the magnitude of v, we're going to use that formula. It comes from the Pythagorean theorem. So that's going to be 6 squared plus -6 squared, which is going to be the square root of 72, but then simplify that to 6 times the square root of 2. So a little bit of radical work there, but you're going to have 2 times 36, and then the square root of 36 is 6, so the magnitude is 6 square root 2. The direction then, so you're going to say the direction is, say right here, I meant to draw it in green, but tangent theta, is equal to b over a. Well, in our case, that's going to be -6 over 6. So remember, this is my a and my b there. Okay, and so that's -1. So I'm thinking, okay, what has a tangent of -1? You could say -45 degrees, or pi over 4. They usually do this in degrees, I think. We would prefer it to be a positive angle. So we're in the 4th quadrant. That's important to remember. So we're going to come around this way and say that's the same as 315 degrees, an angle of 315 degrees. So that would be the direction. Now, in the real world, when you have like boats and planes, they usually talk about bearings and going north and south and things like that. But we're just going to base this on a standard position vector and find the positive angle for the direction. Now, the cool thing about vectors, I don't know if I mentioned this earlier, is you can pick them up and you can move them, and they retain their magnitude and their direction. Now, that's helpful to us when we want to add and subtract and multiply vectors. So that's why vectors are cool. Okay.